following video I will answer the AQA Unit 2 GCSE Higher Maths Practice Paper 3. Okay, let's get started. Question 1. This is about sequences. It tells you the nth term of a sequence is 100 minus 3n. What are the first three terms? Okay, the first term must be 100, subtract 3 times 1. You replace n by 1. And you get 97. The second term is 100 subtract 3 times 2, where n is 2 for the second term, so you get 100 take away 6, which is 94. And the third term is 100 subtract 3 times 3, which is 100 take away 9, which is 91. First three terms, 97, 94 and 91. Could do it a quicker way. Given that you know the sequence is 100 subtract 3n, the negative 3 in front of the n tells you the sequence is going down in threes. So once you have the first term 97, you could read off the next one must be 3 less 94 and the one after that must be 3 less 91. Okay, work out the first term of the sequence that is a negative. So we want 100 subtract 3n to be less than 0. Okay, adding 3n to both sides, we want 100 is less than 3n. So we want n is bigger than 100 divided by 3, which is 33.3. So we want n, a whole number, to be bigger than 33.3. It must be the 34th term. And the answer would be 100 subtract 3 times 34, which is 100 subtract, you would get for that 102, so the first term would equal minus 2. So I would give my answer for that is the 34th term, which equals negative 2. The nth term of a different sequence is given by this. A term in the sequence is 104. What is the value of n for the term 104? So if we know that in general the nth term is given by this, and we know 104 is one of the terms, we could make the nth term equal 104 and solve for n to work out what term this must have been. Two ways to do this, just from here, just to show you two different ways of algebra. The first one, you could expand out the brackets and get 6n plus 8 is equal to 104. Then you subtract 8 from both sides, you get 6n equals 96. Then you divide both sides by 6 and you get n is equal to 16. Or straight away, you could have divided both sides by 2 to get perhaps an easier way. 3n plus 4 is equal to 52. Then subtract 4 off both sides, so you get 3n is equal to 48. Then divide both sides by 3 and you get n is equal to 16 again. Hence the value of n is n equals 16. Okay, next question. A recipe for chili con carne serving 6 people. The following set of ingredients are needed. Leroy is cooking on a camping trip. He wants to make chili con carne for 21 people even. How many grams of tomatoes does he need? Well, he needs 500 grams for 6 people. Okay, so probably the easiest thing to do here is to work out how much he needs for 3 people. How many grams would he need for 3 people? Well, he would need half that, which is 250 grams. But he wants to cook for 21 people, so you've got to multiply the previous answer by 7, so it's 7 times 250 grams. Okay, 4 times 250 is 1,000. Add another 3 times 250, which is 750. That would give you that he needs 1,750 grams of tomatoes. Okay, next question. Simple substitution question here. Just substitute using brackets to make sure you get everything correctly. A is 10, B is 2, and C is negative 6. So AB means A times B, so put it in brackets. 10 times B is 2, then you're going to subtract negative 6. Putting in brackets here really helps you and not confuse the subtraction with the actual fact that 6 is a negative number. And C was negative 6 plus 4. Okay, let's work out the top. 10 times 2 is 20. Minus negative 6 is a plus 6. And negative 6 plus 4, don't get yourself confused here, you're at negative 6 on the number line. You add 1, 2, 3, 4, you get yourself to negative 2. So on the bottom must be negative 2. Work out the top is 26 divided by negative 2. Well, 26 divided by 2 is 13, but 26 divided by negative 2 must be negative 13. So the answer is negative 13. Question 4. Here are 3 expressions. Is there a value of x which makes them all equal? You must show your working. Well, for them all to be equal, in particular, any 2 must be equal. So, for example, if you want equation 1 to equal equation 2, you would write down that 2x plus 5 must equal 3x subtract 8. X is on both sides. Subtract 2x from both sides to tidy it up. 5 is equal to x subtract 8. Add 8 to both sides to remove that negative 8. You would get x is equal to 13. So to make 1 and 2 equal, x must be 13. Let's try and make, for example, 2 and 3 equal. If 2 and 3 are equal, we would have 3x minus 8 is equal to 4x minus 21. Subtract 3x from both sides. You get negative 8 is equal to x subtract 21. Add 21 to both sides to remove that negative, or subtract 21, and you get x is equal to 13 again. And hence 2 and 3 are equal. Okay, so just check, you know that 1 and 2 are equal for 13. You know that 2 and 3 are equal for 13. So 1 and 3 must also be equal for 13. So the answer for this is x is equal to 13. Okay, here's a mobile phone tariff. Plan A. Monthly charge £30. That means you always get charged £30 regardless of how many calls. You get 400 free minutes a month. And after the 400 free minutes, every extra minute is charged at 20 pence per minute. Plan B has a different tariff, it says. The graphs show these plans. So let's just look at Plan A and just decide how that fits in with the tariff we see. The monthly charge is £30. Well, that makes sense because £30 is charged between 0 and the 400 free minutes. So there's where the 400 comes into play. And after that is 20p a minute. So for example, another 100 minutes, okay, another 100 minutes here are costing you £20. So the gradient here is saying that you're getting charged £20 for each 100 minutes. So in particular, you must be getting charged 20p for every minute, each minute, which fits in nicely with what it tells us for Plan A. Just looking at Plan B then, we know that the monthly charge must be 40 and 3 minutes are between 0 and 550. And after that, the gradient tells us how much extra it is per minute. For example, for 100 minutes, it looks like it's 10, 20, 30. For Plan B, it looks like it's £30 for 100 minutes. So it must be 30p for each minute for 1 minute, divided by 100. Okay, anyway, let's answer the question, see what comes up. Complete the mobile phone tariff for B. The monthly charge was £40. The 3 minutes, well, we said it's free between 0 and 550 minutes, so you get 550 minutes for free. The extra minute charge, well, 100 minutes charges us an extra £30, so that's 30p a minute. So it's 30 pence per minute. I have shown my workings over here. In the exam, show your workings here directly with the question. Lewis is deciding whether to use plan A or B. Work out the number of minutes of calls for which plan B is cheaper. So you want plan B to be cheaper. So looking at the graph, you want the time where plan B is below the graph for plan A. So plan A is the dotted one here, and you want plan B to be beneath it. So you're trying to work out the number of minutes of calls for which plan B is cheaper. Okay, so plan B is clearly cheaper where the line is below the line for plan A, so that must be between here and between here. So just reading off your graph, it's 450 here, and here is 750. So just reading off your graph, the number of minutes for which plan B is cheaper is between 450 and 750 minutes. Okay? Right, let's move on to the next question. Question 6. P is a number. 12 is the highest common factor of 24 and P. You've got two numbers, 24 and P, and you know 12 is the highest common factor. Work out two different possible values of P. Well, if 12 is the highest common factor, 12 must go into 24 and P, or 24 and P are in the 12 times tables. So let's list out the 12 times tables of P. You've either got 12, 24, 36, 48, 60, 72, 84, 96, and we get 108. So there are the 12 times tables, and we're saying that 12 is the highest common factor of 24 and P. So 24 arises here. Could we think of another number for which 12 is the highest common factor of 24 and that number P? Well, P could be 12, for example. P could be 12 because the highest common factor of 12 and 24 is 12. And P could also be 36 because the highest common factor of 24 and 36, the biggest number that divides into them both, is 12 again. So another one could be 36. 48 couldn't be because the highest common factor of 24 and 48 is actually 24. Could 60 be? Well, 60 could be as well because 12 goes into 60 and 24 and is the highest factor of both. But 72 couldn't again because 24 goes into them both. So it seems like every odd, so this is the first, the second, the third, the fourth, the fifth, the sixth, the seventh, the eighth, the ninth. Each odd one seems to work out for us there. Okay, question 7a. Two banks calculate the yearly interest they pay the customers. London Bank and National Bank. Talia has 500 to invest for 1 year. Which bank will pay her more? So work this out nice and neatly. First of all, work out how much she'll get in London Bank. She gets 4% of the total you invest. So she's investing 500. So you want to work out 4% of 500. So you're trying to work out 4% of 500. Well, you can do that pretty easily in your head. 1% must be 5. So 4% must be 4 times 5, which is £20. So which will pay her more interest? She is earning £20 from the London Bank. That's very straightforward. Go for National Bank now. It's got to be a bit more complicated for 5 marks. 1% of the first 300. So 1% of 300, and you're going to get £3 there. 6% over the amount over amounts over 300. So she's going to get 6%. For the remaining, she's only got £200 over 300, so 6% of 200. Well, 1% of 200 is 2. So 1% of 200 is 2. So 6% of 200 must be equal to 12. You add those together and she's getting £15 interest. Work out which bank will pay her more interest. Well, London does. And how much extra interest will she earn? She will earn an extra £5 interest. Okay, question 7b. Work out the investment that will earn the same yearly interest at the two banks. The word investment means how much money you actually put into the bank at the start. That is what you're trying to work out. So you don't know it. So to start with, I would say let X be the investment. Now what you're going to try and do is with that investment of X, you're going to work out how much you get at the end of the year in the two cases, make them equal, and solve for X to work out what that original investment had to be to make them the same. So let's remind ourselves, London gives you 4%. London gives you 4% interest. So your investment at the end using a 4% increase percentage multiplier would be 1.04 times X. That's how much you would have at the end, because multiplying by 1.04 increases your investment by 4%. Okay, going back to National Bank, it gives you gives you 3% on gives you 1% on the first 300. So you're going to get at the end of it, you're going to have your original investment of X, and you're going to have 1% on 300, which is £3, and then you're going to have 6% on that over 300. So the bit over 300 is your original investment subtract 300, and you're going to have 6% on that. Okay, let's tidy this stuff up here. That's X, our original investment, plus the £3, plus 6% on that over 300. So multiplying this out, 0.06x minus, well, 1% of 300 is 3, so 6% must be 18. So you get subtract 18. Tidying up even more, that means you have 1.06x, 3 minus 18 is minus 15. So you want the two investments to be the same, so you want this amount at the end to equal this amount. So you want 1.04x to equal 1.06x subtract 15. You have x's on both sides, so subtract 1.04x, that leaves you with 0 equals 0.02x subtract 15. Add 15 to both sides, you get 15 is equal to 0.02x, and divide everything by 0.02, you would get x is equal to 15 divided by 0.02. If you're struggling working that out, well, what's 15 divided by 2 is 7.5, so 15 divided by a smaller number, 100 times smaller, would make your answer 100 times bigger, so it would be £7,500. So the final investment, the investment must have been £7,500 to make your final amount at the end be the same. Okay, question 5a. N is an integer. Integer, again, we see this coming up all the time. That is a whole number. Whole number. Positive or negative. Write down all the values of n. Okay, this should say here, it's a bit unclear, minus 2.5 is less than or equal to n is strictly bigger than 1. So these are the whole numbers that can be bigger than or equal to minus 2.5 but must be less than 1. Those whole numbers must be minus 2, minus 1, 0, but it doesn't include 1 because n has to be strictly less than 1. Okay, 3 inequalities identify the shaded region in this diagram. write down the inequalities. So this is our shaded region, and we know that the dotted lines mean strict inequalities and the whole lines mean less than or equal to or bigger than or equal to. Now x is 3 is this line here, so the shaded region are for all x values strictly less than 3. That's why that one's given to us. Let's have a go at this one. Here is the line y equals x plus 2. The shaded region is strictly below that line because it's dotted, so the equation must be y is strictly less than x plus 1. And this line here, well, it's not a dotted, it's a full line, and the shaded region is above that line. So y is bigger than or equal to, because it's a whole line, 1 minus 2x. And that's quite a simple inequality. Usually they're quite tricky, but that's very straightforward. Okay, question 9. In a sale, the price of a computer decreased by 30%. The price in the sale is now this. Work out the price before the sale. So, if there's been a decrease from 100% by 30%, you now have something 70% of the original value. So 70% is the same thing as £560. Okay, so you could divide by 7 to work out what 10% is. 10% is 560 divided by 7, which is £80. So the original price of 100% must be 10 times 80, which is £800. You could just check that that actually works. If what's 10% of this? It's 8, so 30% must be 240. 800 take away 240 gives me 560, the sale price. Factorise fully 10c squared plus 8cd. What goes into 10 and 8? The biggest number you can think of? Well, 2 is the best we can do. What goes into c squared and cd? Well, a c does. 10c squared divided by 2c is 5c, and positive 8cd divided by 2c is positive 4d. Multiply out afterwards just to check you got the right answer. Simplify 2ab to the 4 all to the power of 3. Now just note here, I'm just going to write something down here, what students might go wrong on. They know the power of the power. They might say 2ab4 to the power of 3. They say the power of the power rule means 2ab4 times 3, which is 12, and they leave their answer at that. That's not right. The brackets here are telling you that everything, not just the b to the 4, has to be raised to the power of 3. So, let's have a go at this again. That means we're going to get 2 to the power of 3. A to the 1 times 3 is a to the power of 3. And b to the 4 times 3 is b to the 12. Now work it out. 2 cubed is 8. So this simplifies to 8, a cubed, b 12. The brackets here are key. Okay, the diagram shows you the sketch of two straight lines. Prove that the lines will never meet. Okay, just a bit of background work in here. Here's a line. Here's another line. At some point in the future, because the gradients of these are not the same, those lines will meet over here beyond the page. So if the gradients of two lines are different, the lines will at some point meet. Thinking about this the other way around, if two lines have the same gradient, for example, I'm pasting this line here, these two have the same gradient, they will never meet. So if the gradients are the same, they can never meet each other. Okay, unless they were the same line, for example, but they're not. If they're not the same line, then the gradients can never meet each other. So in order to prove this line 1 and this line 2 do not meet, we have to show the gradients are equal. So to start with, what I'm going to do is I'm just going to fill in the coordinates here so that I've got a full set of coordinates on the diagram. Here we are 0 across and 7 up, and here we are 4 across and 0 up. So we've got a pair of coordinates. We've got a coordinate on line 1, 2, and another coordinate on line 1, and a coordinate on line 2, and another coordinate on line 2. You will remember that the gradient of a line is equal to the difference in y's. You take the y's away from each other divided by the difference in x's. You take the x's away from each other. So for line 1, we've got the following coordinates. We've got 4, 9. And for line 2, line 1, you've also got the coordinate 0, 7. So the gradient is the y's taken away, 9 subtract 7 over 4 subtract 0. 9 subtract 7 is 2, 4 subtract 0 is 4, so you get a gradient of a half. So for line 2, our coordinates are 10, 3 and 4, 0. So the gradient, subtracting them from each other, is the difference in y's is 3 take away 0, and the difference in x's is 10 take away 4, which is 3 over 6, which again is a half. So then you say gradient same, so lines never meet. Simple as that. Okay, question 12. Make D the subject of the formula. We've seen one like this before. We want to have D equal to an expression here. In order to do that, the D's have to be, you can't have a D on top of the fraction and D on the bottom of the fraction. You've got to take the D's so that they are all either on top of the fractions, for example, all on the same line, and you've also got to release the D's from whatever brackets they're in. So to do this, to start with, I would multiply everything by D to remove the D on the bottom. So you get CD is equal to, and expand out at the same time, 10t minus 10d. You want all the d's together, so I'm going to add 10d to both sides to get this over here, and I would get 10d plus cd is equal to is equal to 10t. Now I'm going to factorize. There's a d here and a d here. I'm going to say d 10 plus c is equal to 10t. That's factorizing. Then I'm going to divide both sides by 10 plus c to get that d is equal to 10t divided by 10 plus c. So d equals 10t divided by 10 plus c. Question 13. Show that the following is a recurring decimal. Well, it sounds hard, but actually it's not too bad. Let's work out what each thing on the top and bottom of the fraction means. 3 to the 0 is 1, because anything to the power of 0 is always 1. 27 to the third means, and you need to know this, the cube root of 27, and the cube root of 27 is 3. So therefore this fraction, 3 to the 0 divided by 27 to the third, simplifies to 1 over 3, which you know is 0.3 recurring. So you could just write 0.3 recurring in here. Work out 4 to the 5 over 2. You want to work out 4 to the 5 over 2. I've shown you in previous videos that what I think you should do is write the 4 to the unit fraction 1 over 2 and raise that all to the power of 5. So write this as a unit fraction and take the 5 outside the brackets. What does 4 to the half mean? Well, it means the square root of 4 all to the power of 5. The square root of 4 is 2, so that's 2 to the power of 5, and 2 times 2 times 2 times 2 times 2 is equal to 32. Okay, question 14. Here is a formula. R is the square root of y squared minus x squared. Find R when y is this and x is this. We've seen one exactly like this in a past paper. The way to do it is to firstly work out y squared. Y squared is 5 root 2 squared, which is 5 root 2 times 5 root 2 times the numbers separately. 5 times 5 is 25. Root 2 times root 2 is root 4, which is 2. 25 times 2 is 50. So y squared is that. What's x squared? Well, it's root 6 squared, which is root 6 times root 6, which is root 36, or 6. So r, being the square root of y squared minus x squared, is therefore the square root of 50 take away 6, which is the square root of 44. Now, have we got it in the correct answer here? They want you to write your answer in the form a root b, where a and b are integers greater than 1. Ask yourself, can you think of a square number that goes into 44? The squares are 1, 4, 9, 16, 25, 36, and 49. 49 too big, 36 does not go in, neither does 25, 16 does not go in, 9 does not go in, so 4 is the biggest one that goes in. So you write that as the square root of 4 times the square root of 11, which is 2 root 11, because the square root of 4 is 2. Hence, your answer is 2 root 11, a is 2, b is 11. Both are integers. Okay, last question. Question 15, solving simultaneous equations. Label them 1 and 2 to start with. Notice, equation 1 is linear. Equation 2 is quadratic because it's got x squareds in it. So, I always say substitute the linear one into the quadratic one. So the first line would be to substitute y equals 1 minus 2x into equation 2. Now by that I mean, where I see y in equation 2, I'm not going to have y anymore, I'm going to put 1 minus 2x in its place. So my next line would therefore be that 1 minus 2x must be equal to x squared minus 3x minus 5. Remember, all I've done is, instead of putting y in, I've put in 1 minus 2x into equation 2. I have a quadratic equation because it's got an x squared and an equals. I can't solve until I make equal to 0. So I'm going to add 2x to both sides, and I'm going to subtract 1 from both sides to remove these. And I'm going to get 0 is x squared. Okay, minus 3x plus 2x is just minus x. And minus 5 minus 1 is minus 6. Now we're going to try and factorize. Two numbers that multiply to negative 6 and add up to negative 1. Well, what times is to 6 first of all? 6 and 1, 3 and 2. Can 6 and 1 ever in any way add up to minus 1? No. Can 3 and 2? Yes, if you've got negative 3 and positive 2. So this factorizes to x and negative 3, x minus 3, and x plus 2. Two numbers multiplying to give 0. Either this is 0 or that's 0. So x is 3 is one solution, or x is negative 2 is the other. Now I need to find y to check they work. Well, to find y to get a full solution. So if x is 3, y is 1 minus 2 times 3, which is 1 minus 6, so y must be negative 5. If y was minus 2, 1 minus 2 times minus 2, minus 2 times minus 2 is 4, 1 plus 4 is 5, so y is 5 is the other solution. Here's one set of solutions, here's the other set of solutions. Substitute them into the equations at the end to check they work and make sure you haven't made a mistake along the way. Thank you very much for listening. I hope this helps in your revision.